So, with this reaction, you guys have two different chemicals. The two chemicals that you combined, as I pull this up, are your baking soda, sodium bicarbonate, and when we look up here, that is sodium, hydrogen, carbon, and 3 oxygens. Okay? So it's a fairly simple molecule in terms of total number of atoms. The only thing kind of crazy about it is it's got 3 oxygens. But if you look up here how it's put together, it's pretty straightforward. You got these 3 oxygens floating around the outside of this carbon molecule, and then you've got a sodium molecule kind of attached out there. Okay. White powder. What did you guys notice about it?
It started fizzing.
Well, we're not to the reaction yet. What do you notice about the powder itself?
It felt like the same as in the balloon.
Okay, kind of felt the same in the balloon. Was this soft or was it more sandy and gritty?
Soft.
Soft, kind of, okay. More soft. Did it have a smell?
Yes.
It did? Sort of, kind of? Not something you can really describe, though, right?
Yeah.
Okay, and then the other thing, it's 100% dry, right? Like it's not wet at all. Do you think that water is inside of this in any way, shape, or form?
No.
Okay, keep that in mind. Now, the next chemical that we use is acetic acid. In vinegar, right here, this is 95% water, 5% acetic acid. Okay? That's all vinegar, distilled vinegar is. If you get apple cider vinegar, there's more impurities in there, so like leftover sugars and stuff. But this is straight acetic acid and water. I'm going to pour out 250 milliliters. That's 10 times more vinegar than you guys used in yours. And I'm not even going to be that careful doing it because I'm not trying to get a specific result, just the reaction itself. Okay. Just to demonstrate to the people at home, blow up the balloon. You twist it. The reason you twist it is so you can open this up. Put the lip over. So, I do that. Untwist the balloon and let it all pour in. I guess like how. You want? Hey. So, got my baking soda in there, my sodium bicarbonate. All right, gonna let that out. Now, while I'm letting the air out, the acetic acid, it has an extra carbon that this one doesn't have. It has 3 extra hydrogens that this one doesn't have, but it has 1 less oxygen and 1 less sodium because it doesn't have any sodium at all. Okay, this is important. So what you guys are seeing before I make this reaction happen is 2 separate chemicals. Each has their own properties, unique properties. What did this smell like? Vinegar, right? It's got that real strong vinegar smell. It's clear. Can't see through it. Okay. When I do this reaction, these things are going to swap parts. Not the whole thing, but these guys are going to trade. And that's what happens in chemistry is things trade with each other. It's a very... You ready? Now, the same thing is happening in mine that happened in yours, only I've just got more, so I should receive more of the reaction. Now, unfortunately, I think I got a hole in my balloon somewhere, so I'm dripping. So, what did we say is the gas that's filling this up?
No, carbon dioxide.
Carbon dioxide. Good. Now, there's a couple of ways that we can tell this is carbon dioxide. Number one, the only possible thing this could have inside of it is carbon, oxygen, hydrogen, or sodium. So that limits the list of things that this gas could be. But one way we could test this is if I were to blow up a balloon and then just allow the air in here, so do it where we mixed it in here and let the air escape. I could tie them both together, drop them, and the one with CO2 will drop faster because it's a denser material. And I've done that in years past. It worked out. Okay, so things that we noticed about this. What happened to the temperature? Got cold. This one right here, I'm going to walk around. This one's really cold. You can really feel the difference. So, yeah, it's like refrigerated, like I just took it out of the refrigerator. Cold. Right. Now, as we mentioned, since this got cold, what type of a reaction is this? Anyone know?
Sodium acetate. Sodium acetate.
Well, there is sodium acetate in this. You guys feel it? It's really cool. Now, I'll ask the question in a different way. If it got cold, did it add energy or did it take it away?
Take it away.
Boom. That's the answer. It took energy in order for this to happen. In order for the acetic acid and sodium bicarbonate to actually react, they had to steal energy from the environment. So it made everything cold. This is called an endothermic reaction. Okay? So you guys created an endothermic reaction. We took energy away. Now, here's some other things to talk about. The gas we said is CO2. We can test that. What about the smell? Ooh, this has really got it. You guys need to smell this. This is perfect. So, this is what happens. So, these are our reactants. These are our products. Which one of these three things is the thing that smells like fingernail polish?
Sodium acetate.
The sodium acetate. Because water doesn't have a smell and neither does carbon dioxide. So when you smell this, that's what you're smelling. And that sodium acetate is very similar to a chemical that we use. It's another acetate for artificial banana flavor. This has a slight hint of banana. And this is one of those types of compounds. It's one of the types of compounds, not the specific one, that we use to make artificial flavorings. So, things to think about as we go through this. Down here below, I'm asking you guys to account for the number of atoms in this reaction. This is a lot less complicated than you might think. I'm asking on this side, this is the reactants, right? The left side, the stuff we're mixing. Okay, count the number of carbon atoms, write it down here. Count the number of hydrogen atoms on this side of the equation, write it down here. I'll do that for you on this one. You guys pay attention? Check it out. 1, 2, 3, 4 hydrogens, 5 hydrogens. I'd write 5 down. Carbons, 1, 2, 3 carbons. I'd write that down. I'll do that side. Then I go over here, and I got to count it up over here as well. Now, before you do that, let's talk about this reaction. Because here's the cool stuff. This should somewhat blow your mind. You guys ready for this? Okay. The white powdery substance, sodium bicarbonate. It gave away its sodium. I told you these guys swapped parts. The sodium bicarbonate gave its sodium to the acetic acid. And what the sodium bicarbonate got in return was a single hydrogen. Here's how you know that. You guys really got to look up at the board to see this. If you look, acetic acid and sodium acetate are identical, except that the sodium acetate has one less hydrogen and a sodium. That's the only thing that's different between the sodium acetate in here and the vinegar, is this has a sodium and one less hydrogen. Now, the hydrogen that it gave away, it gave to the sodium bicarbonate, and the sodium bicarbonate turned into water and carbon dioxide. So, this is the mind-blowing part, because I'm seeing no one's mind is blown yet. We turned this into water and gas. You took a solid, and you turned it into a gas, and you turned it into a liquid simply by mixing vinegar. You turned a solid substance into liquid and gas. I didn't need the wow. But that's what you guys just did here. So that's one level deeper than what you had before, because before you just knew it fizzed. Right? Now you understand why it fizzed, but now you know what's going on. Like you literally changed something into two different states of matter. So you saw today all three states of matter come from one chemical. All right. What I want you guys to do is finish up